Welcome to the earthquake. Let's just scroll it down just a little bit. We want to give the name. Can we scroll up? Yeah. It says Earthquake Recording Station. This is for the 8th grade, I believe. It's the recording station. And we're going to be using words like epicenter and focus. So, where do you think the epicenter or the center of this is going to be? It says in the bottom here that the thing with the circle might be the earthquake, and the A is where our station is. So it's going to go boom here, and we're going to be recording over here.
What does it say in the first click play and observe the?
Yeah, we should say click play and observe the seismic waves. Something's going to happen now if we hit play. Boom, here it comes, here it comes, here comes the wave, here comes the wave. Boom! Oh, we just saw something over here.
Because
here
it's
it comes,
blocking
boom!
it,
Here
right?
comes again. Yep.
Wow.
So there were 2 big waves. That's what I saw. So apparently there are 2 kinds of waves, P and S waves. That's one of the questions. What are the kinds of waves? They have P wave, which is the primary, and S means secondary. So if we look at this again, here it comes, here's the primary, boom, it hits, and that's the first one that hits. And here comes the secondary, lots of shock. And apparently the distance here looks like 600 kilometers this way. It says 100 kilometers. Oh, I see. The location.
Okay, so what's our next question?
Oh yeah, what's the next question is
Observe.
at what time did the P wave hit? Well, we have a time here, and then we have another time here.
Yeah.
Oh, I see. The time
The
is
time
shown
here.
with 550.
50 second and 200 second, right?
So that's the 50,
Let's reset it.
and that's
then
200.
again.
Okay.
Okay.
P is boom, right there.
Right.
And here comes the second, boom, right there.
We have to look for the time here, right?
Right, looks that.
Okay, let's do it again and see the time.
Well, I think we can see it just right here. Boom,
Oh,
right
it's
there.
182
Can we
seconds.
move this over? Yeah, you can move that over to here. There we go. Move it a little bit over.
Right.
That will be the
Got it,
start.
got it, yeah.
Right about there. And then this one will be the second.
Yeah.
And I think it started right about here.
So we don't have to watch the time. We could just
Oh, how
simply move
nice.
this.
They said it's 100 seconds difference.
Wow. So the difference was 100 seconds.
Right.
The first wave, which was the P wave, right?
Right, the primary.
The primary wave hit at 160 seconds, and the secondary wave hit at 260 seconds. Okay, what else do we need to do?
They're asking if you were at the recording station when it hit, what would you experience during the earthquake? What do you think we'd experience at this point, and what do you think we'd experience at this point?
So they need to
They
figure
need to
out.
think that out, right?
Okay, what
I'm
else?
hoping this looks like it was smaller, and this looks like it's longer. So I think we might see something different if we were watching some books on the shelves. Students who are watching this, what do you think would happen to some books on a shelf at this point? And then there would be maybe quiet. And then what would happen at this point?
So the primary waves, which like they are less destructive than the secondary ones, I guess.
Right. It's interesting. It's 100-second difference. So
Right.
could this be something that maybe animals experience? 100 seconds is almost 2 minutes. So perhaps the
the primary waves, they
Maybe that have
They
you heard
sense,
stories
right.
about animals running
running and
and then the earthquake hits? I'm wondering if the animals are feeling something like the primary wave first,
right.
and they start running.
Is there anything else?
We're supposed to click. We're trying to find the distance to the epicenter, so we click reset, and we place the recording station 300 kilometers from this. So we have to hit
Okay,
reset.
change that, okay?
What's
Yeah,
that?
I did reset.
Yeah. Okay. So now we're supposed to move this 300 kilometers away. Oh, I see. We can put that anywhere. Oh, you want to put it exactly. That's an interesting idea. We could, like line it up so we know what the distance is.
Okay, and now?
Can we move this down here? Then it will just be a straight line. Okay. Now,
Okay.
this is assuming how much is for each one of these? Is it like 50? Oh, see, it says 400. So we need to move the epicenter a little closer, or
How much is the distance they want?
they want 300. There we are.
we
Up 290 and 300. There it is. So now we will wait until this. We're supposed to look at the time distance. So, okay. How do you think the time difference between the first P wave and the first S wave will change as the distance to the epicenter increases?
Okay.
So if we move this, will there be more of a separation? That's
Okay.
what I think they want us to find out.
Right.
So we should hit the play. And boom, boom. Wow. Almost no distance at all here.
No time difference, right?
Night time, yeah. It's from there. And then we should put this over. And I think that's it.
Within 39 seconds,
39
both the waves.
seconds. Remember the other one was 100 seconds.
Right. So this is this is the earthquake, right? This
Right.
is the location of the earthquake, and this is the location of station.
Mm-hmm.
What station is that?
This is the recording station.
Recording station.
And it's 300 kilometers away. Before, it was more like 600 kilometers. So there was quite a bit of difference here. They're asking, how do you think the time difference between the first P wave and the first S wave will change as the distance to the center increases? Let's
let us increase.
double.
Yeah,
Shall we
let's
double
double
it
it.
and
Yeah.
just see what happens?
Yeah, let us move it. Okay.
Oh, we
let's
have to reset, I think, yeah.
And let's move it to 600.
And there we are, we're at 600.
Okay, now let's see.
Okay. This is going to be fun, students. Here we go. Bam! There's the first
I think it
one
will
there.
increase.
I wonder if it'll be exactly like
Wow.
double. Who knows?
Right.
We will find out.
So this was here.
Yeah.
And
The
this
first one was like 39 seconds.
Right.
Look at that.
76.
It's about double,
Yeah.
more or less. Because if we were not exactly, if it had been 38 seconds, this will be exactly double. So where we place these buttons is very close. So
Let me
when we
try.
double the distance, we
Yeah.
double. Oh, wow! You want to make it more
Yeah,
interesting.
Right. I want to make
All
that
right.
from here.
See if we get
all
1,000
the
or
way
something.
Here, if you are too far from the earthquake.
Oh, maybe if
Okay.
we can double it to 1,200.
And you know what, Mr. Steve? I think this the center, recording center,
Yeah.
it could be a house, it could,
Could
be,
be.
anything, right?
Right.
And
it
this
could.
particular place, the waves are hitting, right?
Right. And
Okay.
who knows what effect the kind of, whether we're going through something. Can we make that a little more so it can be exactly double?
Okay.
Yeah, because we're almost
How
at
much? How much?
1,200. If we can get to 1,200, it will be
Okay.
double. So yeah, keep going a little bit more. Good. Oh, there, 1,200 is so close. That's very close. You had 1,202, which I think is just fine.
I want to get exact.
Oh, I
100.
know you want to get exact. That's fine for me.
1,200. Okay,
Yeah.
102.
Okay.
Okay,
So we think that this will be double the 76.
let's see.
Yeah. Here we go. Here come the waves. Here come the waves. And
Boom.
boom, right there.
Okay, and there's the
And
second one.
boom, there's the second one. there.
Okay.
Okay, so I want the first one to be
Here.
No, oh no, that's the second one.
Oh yeah,
Yeah,
this one.
That goes. Hey, I wonder if there would be any difference. Okay, and right there. Look at that. 148. Remember the other one was 76?
76.
It's very close. Very close to double.
So that means that the farther they are, the longer time it takes.
Right.
So there would be 2 earthquakes.
This
And
means they can double. Yeah, and there will be a big separation.
Yeah.
A small earthquake and a big one.
Yeah.
So using this, we can estimate for every 100 seconds, there's perhaps so many kilometers.
So that means, Mr. Steve, this is the epicenter, right?
Right.
From where the waves are generated, right?
Right.
The waves
Yeah.
are coming from here. So if we are living in the area closer to the epicenter, we are in a great danger,
I think so.
right?
Yeah.
If an earthquake happens, there would be a lot of destruction.
You know, something I was noticing, when it was so close, this was moving much higher.
Really? Let's try.
Yeah,
Let's see again.
when you get it very close, it was going more than because it was so close. Yeah. Let's put a real. Ooh, this will be fun.
Okay.
Yeah, this is only 100 kilometers. We're going to
Okay,
go
let's
boom,
see.
boom. Oh, this will be fun. Bam, bam. Oh, look at how strong that is. Do you remember? Oh
Right,
my
right,
goodness, these poor
So
people.
the closer they are, the stronger the waves are.
Right, and they arrive more
And
quickly.
they arrive more quickly, right?
Look at that. What was? Oh, we better find out what the time difference is. I'm expecting it to be very low.
Very low.
Yeah, there it is. 13 seconds. Just for 100, where it was close to 39, which is 3 times this, when it was at 300.
Okay, for
So-
we could say for how many
For every 100,
100,
it's 13 seconds.
So
That's a good way to predict.
right. So
So-
if we make it 200,
We should make it 26.
yeah.
I'm guessing.
Let's see.
There's our
For
200.
100, we had 13, right?
Yeah. Bam, bam.
Okay.
All right.
So
This is our estimate. We're pretty good at geology, I think. Haha. Oh, this will be interesting. Will it still measure it if you put the blue one in the first position?
so 13.
Well, it's about double of 13.
Right.
About, yeah.
Wow. So
Quite
if
nice.
as the distance is increasing, the time difference is increasing, and the waves are getting stronger or weaker.
Oh, yeah, and the wave gets weaker as we got farther away. We hope that this has been a helpful
Let's try
gizmo
these
for you
questions.
students.
Let's try these questions if possible.
Oh, yeah, okay.
What is this? In
Right
which
here.
seismogram is the time probe placed at the beginning of the P wave?
At the beginning.
Beginning.
I'm looking that the P wave should be the short one, right?
Yeah.
Aha, so it's not
These-
here.
These are all P waves, the primary waves.
Well, the P,
So the
P waves
beginning-
is this one. These are the secondary waves.
No.
Yeah. See, the P wave is the little
P-
guy.
Oh,
Yeah,
okay.
yeah.
So these are the P waves. The small ones are P waves, and the longer ones are the S waves.
S wave, the
So
secondary.
they want the beginning of the P waves.
So if I'm a scientist, I'm looking for the little one. That looks like your answer.
This looks like the beginning.
Yeah.
So seismogram C.
Good. When looking at this question, I see that they have the same position for the
Right.
small one. So we just have to see where
Is the
they
big
decided to
one,
put
right.
that big line. That was a nice question.
Okay, suppose that an earthquake has just occurred,
Oh boy.
as pictured below. The first P wave is shown as the larger circle,
There's the P wave. Here it
and the
comes.
purple one